Our next presenter is going to help us talk through that. He has a lot of expertise in safety systems and has consulted with many name brand companies out there, the ZF and others, to name one. So let's welcome to the stage to take on this challenge of rebooting for software-defined vehicles, Milan Malika.
Hello, thanks for the nice introduction. I hope you can hear me well. So first of all, I'm very happy to be here again. So I was here last year for the first time. And we are continuing on the journey of finding the next buzzword to invest in for the investors. So the autonomous vehicles, level 4, 5, and full self-driving was one of them. And now we are downplaying it. And now we have the software-defined vehicle as let's say, pot of gold to take from or to pour in, however you want to put it. So my current role is here in this part, I'm the functional safety instructor and leading functional safety team within the University of California, San Diego Extended Studies Department, where we are fueling the industry, believe it or not, with an in-depth hands-on functional safety upskill program that is available each fall for the complete world, basically. So it's an international program that we administer from California. I'm also leading the NIT Institute, providing consultancy services in functional safety and in different transformation agendas for companies. And today we are going to see a bit on how this works and what are the challenges in this domain. Okay, so let's start from the SDV conceptual architecture. I simplified it a lot for the sake of the audience to be able to grasp what are the real challenges there. So we want to basically reduce vehicles to basic vehicle elements, so to the I/O. So let's look at different vehicle elements like sensors, part chain, chassis, battery, etc., as simply elements that can be controlled or can provide information at the very minimum level of semantics. Okay, so we are not putting smarts in those vehicle elements, and this is where we want to reduce our vehicle to this complexity in the sense of hardware, and everything else we want to move in something that we call automotive software platform. This box here is a software block, and you heard a lot of words that can describe this. Of course, at the core of it is a real-time operating system. You have really good one here at the conference as well. Hypervisor technologies, deterministic communication technologies, safety controllers, and different safety stacks. Different ways how to provide freedom from interference using all this. How to deal with scheduling that needs to be deterministic. How to provide diagnostics, logging, etc., etc., etc. So this automotive software platform is something that is a bare minimum to be safety critical, to solve safety critical challenges, and it exists currently in the industry. But when we are speaking about the conceptual architecture for SDV, we need to bring it up a notch. We need to provide something that is here called the software model. So we need to model the complete vehicle using software paradigms like we do on the cell phones, like we do in the object-oriented programming, etc. So we need to find a way to allow the programmers, to allow the software developers and engineers to play with all those blocks in a sense of objects rather than in a sense of hardware elements, okay? And then we are bringing up the semantics here. Instead of dealing with this traditional automotive software platform semantics that are more, let's say, programming kind of programming level and programming requirement, we have here, let's say, more of a design and modeling things, such as different ways to deal with perception, decision, control, V2E, V2X, etc. One simple, let's say, reference would be if at the vehicle elements level we have a sensor, let's say a camera. At the platform level, we have a camera driver that allows us to, get buffers and process and push into the pipelines, etc. At a software model, we have an object, a perceived object, okay? We want to deal with the environment, with objects. Let's say you have a car, you have a pedestrian, you have let's say you have a region, in the world that you're mapping this at. So these are the problems that we are dealing with at this level. However, those are still not the applications. So those are still bits that we can use and influence to build our application. And this is a very, very good opportunity for the industry to build upon this middleware, or what I hear called edge twins. So this is basically the modeling of the complete vehicle and the world at the edge. So it is still inside the vehicle. And then on top of that, we are building functions, we are building use cases and applications. Whatever those might be in terms of autonomous driving, in terms of different other functionalities. Alongside, we have the runtime environment that needs to run those apps and to make available all these software model blocks for the applications, algorithms, and functions. And usually we have a very prominent block here. OTA maybe is not today maybe it's not the best name. So OTA, over the air update, actually is the software upgrade mechanism that goes together with this middleware concept, so that you can upgrade apps, you can install apps, uninstall apps, you can, let's say, do different updates in your algorithms, perception, etc. This is one of the key traits of the software-defined vehicle concept. And then it cannot go without the cloud services part or without the vehicle digital twin. So basically, you're replicating whatever you have in the software model to the cloud. So in the cloud, you have the same vehicle, the same state that is being replicated, and it exists there. Why we need that? Because we have a heavy backend operations, headquarters, data and fleet management. Maybe we are training, maybe we are learning from the vehicles. We need to manage all the versions of apps. We need to manage app stores. We need to do all that. So these are the challenges in a nutshell that a software-defined vehicle, realm deals with, okay? What is here defined then by software? So everything starts basically, of course, we have the cloud apps defined by software. Of course, OTA engine, RT, all the apps, all the modeling parts of the software, so these are the things that are usually being updated. I'm not saying that you cannot update the automotive software platform, etc., but usually you update your middleware blocks that deal with different particular abstractions. You upgrade apps, you upgrade your functions, you're upgrading the environment and all the apps and functionalities. And one of the key traits of the software-defined vehicle is that you can change it during the vehicle life cycle. And this is very cool. This is what we got used to having in the consumer industry, and we want to have it in the automotive. We learned how to create a software platform. It's kind of resembling that we might be able to pull it off for the vehicles as well. Software that changes. What does this mean when we say that software changes? Now, getting back to the topic of this conference, does this mean that the system also changes? Okay, so each time you upgrade the software, you're basically ending up with a different system. No matter how small this upgrade is, this system also changes. Does it mean that our analysis, our safety analysis also need to change? Like hazard assessment, risk assessment, it also needs to change. Threat analysis and risk assessment maybe needs to change. Maybe we have a different attack surface, different risk related to cybersecurity. Okay, let's imagine we redo all those analyses wherever we do the update. I know that it is not so frequently found. In software, when you have a small patch, okay, just patch it and push it on. So let's not redo everything. And the rationale behind it, it probably does not affect anything. But actually, can you be so sure? So we need to do all those assessments again. And of course, it doesn't mean that safety and security requirements are changing. So if those are changing as well, this might mean that we need to change our safety and security measures to stay safe. Okay. If those safety and security measures are implemented in software, we might as well update them through the OTA. Okay. But is only the software model the thing that you need to update? Because we know that when we are looking from the system perspective, you have different system elements, a lot of which are hardware elements that are also in this that you cannot update. So it might mean that not every upgrade can be pulled off. Okay, so some upgrades would need the revisiting of the hardware elements, maybe upgrading them. So you need to recall the vehicles physically to kind of change the full hardware installation. Sometimes you can play with the demand, etc., so to affect the wear and tear and these lambdas, but it's more rare than usual to be able to pull that off. The problem here is to understand all this, should the company also change? What does it mean? When we are talking about the software and these update paradigms and these abstractions and these middlewares, RTs and whatnot, usually we have a bunch of people that we kind of transfer it from the world of software engineering, and the Silicon Valley is full of those, okay? Even the big OEMs and tier ones created new software departments where all the software people are pouring in, and software people usually do not have adequate training in safety, in cybersecurity, in those kind of areas. The mentality of software people is more or less set up back in the 80s and is now the same. That says, okay, you have a bug, you debug, you try again, you debug, you try again, you debug, you try again. Now with all those tools that you have at disposal to develop and debug fast, you would rather just change a code and try again than systematically analyze what would be affected by that. So this is a huge mentality that pours into the world of automotive now that can be troublesome, can be problematic. I'm not saying that companies are not doing anything to tackle that mentality, but just imagine having somebody that, I was working for companies that we had people that didn't even test the code before committing to the code base. Just there's a QA department, not even the sanity checks. So once you run the code, immediately you have problems. And then the QA department kind of have some kind of usually ad hoc testing principles, like trying something high level, whatnot, and then figure out the problem and then pushing that back. And then these people are busy fixing those bugs without regression testing, without anything. So it can be pretty problematic. And the notion of a bug in a software is something that is normal. So when at one point there was a manager of a project that approached my team and said, is there ever going to be a situation in which you will not have bugs in the software? And we were like laughing to the guy, like it's not possible. So bugs are the part of software development process. But now when I started thinking more about safety, then I'm thinking, should bugs be the part of software development process? So can you actually do the systematic development in which these bugs would not be normal situations? So it would rather be an anomaly, residual thing. Something that happens very rarely according to the safety standards. How do we tackle this mentality through the company transformation? Can we actually transform these companies? This is something that we do at the University of California. And one common, let's say, scenario that plays out is that there's usually an innovative software company that, develops some fancy algorithms, applications, something really nice. They have nice demos to show. Sometimes it's even an automated tech, some nice looking infotainment or digital cockpit environments or whatnot. And they show that around at the trade shows and these conferences. And then at one point they clash with an OEM or with tier one, and these guys say, oh, it's great. We want to use that. We want to work with you. Or maybe in the future it would be a legislator as well. They're starting to get more wiser as the time goes by. But traditionally, those were tier ones and OEMs. And then at this point, only that I hear more seriously about some standards, tier ones usually say, okay, what about TSATs? What about ASPICE? What about ISO 26262? And these people say, oh, yeah, we have something. Okay, and it's usually it's nothing, or they kind of started scratching the surface. Maybe they heard something about it. But the culture is definitely not there. So they're not doing it by the book. And the question is how to move fast in that situation. It's pretty hard. Usually their product developed up to that point is just a specification for a rework. An integration project that is about to commence with the tier one or OEM is actually not an integration project. It's just called an integration project. It's actually a rework project. Basically, the full team is being employed to develop the same thing, just in the right way, usually using the tools and full environments from tier ones and OEMs. And this is something that the companies could mitigate by getting ready, changing their culture up front especially if they want to monetize fast. What is the first approach that those companies are taking? Usually they find a person, I call it pretty bluntly, with a huge head, like somebody that knows everything about safety and security. And then, okay, this is our magic ingredient to establish the QMS, the QA, and kind of introduce all the standards. And usually this person ends up dealing with the teams that have no clue about this and ends up bringing in documentation from other projects or other customers that are changing headers or playing with the templates and whatnot, and then trying to kind of force the company into safety. And this is something that rarely happens correctly. Is there a systematic and measurable way to change? We believe it is, and I'm going to demonstrate a few simple steps that can be taken for this culture transformation of the company that we also do as NIT and UCSD. So we have three elements to tackle. So the first one in the culture is the structure and the know-how. Okay, so these are the three very important elements for each company to be tackled. How do we transform the culture? So we have a program that we call Culture Transformation in Key Areas Upskill. It's an upskill program. It lasts 3 or 4 months alongside work for each individual to get from the point of kind of generic engineering knowledge to the applicable knowledge in next generation challenges, including safety, security, and architectures for automotive. This culture transformation in key areas upskill consists of 4 steps. So first step is the landscape training. So you need to provide one training that gives system level landscape about the technology that this company is working with. Usually you should use the terminology that this company uses. If it's a software-defined vehicles, we had one course that we call Kuwadi's SDVs. So usually the outcome is to understand the tech and to onboard people onto what the software-defined vehicle actually means. So what is the architecture of the electronics and the software, etc. What are the communication interfaces? Simply to position themselves correctly in the gamma of automotive hardware and software world. Okay, so this is the first training that you need to provide to people. The second training is what we call a system level training. We want to shift from the particular software mentality into the system level mentality. So we usually have our course that is called Systems, Functions, and Safety. It can be a customized version of it to really have the outcome of pushing people to think top down, to do delineation, to understand the risks, impacts, quantification, and actually to understand the safety process and security from beginning until the end at a very high level. So to understand what this development is all about and what the terminology is all about. Then the third step gets more serious because we are speaking about software people. We are entering into the process framework training. Here ASPICE is usually used to actually enforce and embrace systematic development processes and systematic integrity of their solution. And here is where you introduce specific tools, specific best practices and everything to people, and teaching them how to apply whatever they understood from the step 2 into the particulars in the step 3. And then only when you set up the foundations, you can talk about standards. So only in the step 4, we introduce key standards training. For example, if the company deals more with, security critical installments, then we are tackling ISO 21434, or it could be ISO 26262, depending on the company. Of course, we'll touch on the complete standardization framework that is required, but we can drill down into the most important standard in the step 4 to understand all the nuances to be applied and in the end included in the safety and security case, in the audits, etc. So these are 4 steps that usually can be followed in every transformation upskill, and this is just the top part. Then we have domain-specific trainings that are defined for every particular individual. So individual upskill trajectories. So people need to know new things about AUTOSAR, about Rust, about different specific frameworks, about in-depth take in QA, in system safety, in functional safety, in fault tolerance, etc. But not everyone is going to need all of that, okay? So the previous part, so the upper part, culture transformation in key areas training, you do it for the widest possible audience in the company, okay? If not everyone, then almost everybody. These domain-specific trainings are individual trajectories, so you add up a few trainings depending on the area where this person needs really to excel. And then finally, via consultancy, you can tackle the transformation of your company while you are conducting the training to establish QMS and formal introduction of QA processes and relevant standards, all the way to company certification. But you need to provide that after you finished at least this CTKA trainings, so that you have a team that is on board with you to be able to do this transformation. How the training looks actually. So it's not a bootcamp training that you kind of, go and listen for 3 days and you get a bunch of documentation that you just take home and do not learn it. So the model for the training is we have, for example, one training, if you're talking about 4 CTK training, one training lasts for approximately 1 month. And during this 1 month, you have one sample week, let's say, that we call Discovery Week. In this Discovery Week has 5 work days, out of which 3 or 4 days are used for the course, but not full-time. So each of those days has the async preparation. So it's about 40 minutes in the morning over coffee. So you are watching the digest video, you are preparing for the comprehension of the module that is due in that particular day, okay? It's over coffee, before work or right after you come to work. So you come to work before the rush hour, so at 8, let's say, and then you watch this video or look through the materials. And then you do your regular routine in the workplace, okay? So from 9 until 3 p.m., you do your thing at the workplace. At 3 p.m., usually, there is a live session that happened. It's about 1 hour and a half that we just recap on this async part and immediately jump into the hands-on group work, do the presentations, do the QA, and close the session. So this is how we can make sure that the outcomes are met, so that the module in, module out, people are actually working. You're pushing on things to people. They're always collaborating and always solving things live. So this is very, very suitable for the online training model as well, because people don't have a chance just to listen to presenters and go and walk the dog or do whatever they want to do. So it's not going to happen in this model. In this model, each live session is interactive, so you cannot do any other way. And of course, it's fully backed with the learning management system where they can submit their work, can get feedback, do quizzes, get written comments, discuss via platform, etc. And this happens during the Discovery Week. We cover 3 or 4 modules, 3 or 4 topics, and then we enter into the Productivity Week where now the participants need to solve the project. The project intro also happens in a form of the async video, and then the project setup live session is one live session where we reveal the project, do the project planning, review for each team what they have planned, and then they're on their own. So they have their team meeting, individual work part, live consultations with the instructors, and then they are into the project presentation live session where they now present what they saw. So for the, let's say, it can be to do the system requirements, let's say, for a particular system, to perform system delineation, to do the hazard assessment, threat analysis, whatever is the project, but they're going to do that on their own, okay, without too much assistance. And this is where they're going to apply the knowledge that they apprehended from the previous modules. Here, the effort is also going to be moderate, meaning that you can still work and learn, okay? So the thing about the upskills, you don't want to evacuate your team for the upskill, okay? So you don't have such a luxury of time as a company. So you need to provide the process in which the upskill happens together with working on projects. So you can keep people ideally 6 hours during each day in the workplace. If you want to be ambitious, you can force people to work for 8 hours and then do the training for additional 2 hours. It's probably too much. So decreasing the workday to 6 hours would be probably ideal. So this is how one training looks. So depending on the duration of the training, it can be 2 discovery, 2 productivity weeks and the exam, or it can be 2 discovery, 1 productivity week and the exam. It fits more or less to 1 month. Okay. And now when we are looking at the full transformation of the company, here is an exemplary timeline. This company was, the headcount in this year was about 300 people. Okay, for 300 people to go through the transformation, we had CTKA. So this is the key transformation, the CTKA part. If you see, this is the dark purple part. You have 4 months, 4 trainings basically. So one individual, let's say, enters the training end of September, beginning of October, and then this CTKA groups 4, 5, and 6. So this person is in one of the groups, runs through this fundamental training all the way to the end of January, and then has in his individual trajectory 3 additional domain-specific trainings that were selected by his team leads, or he selected on their own. And then at the end of April, this person goes out of the transformation pipeline. Okay, so the transformation for one person here finishes in 7 months. That is absolute duration, and during those 7 months, this person was active on projects and was contributing to the company, so not only doing the training. It might seem a lot, but this is the only way to do it right, okay? And this is our deep impression from what we have experienced with companies. And this is the only way to actually do the transformation that can work in a long run. Regarding the consultancy part, depending on the requirements, what you want to achieve, but of course, this is just example for one of the customers. We can provide ASPICE certification, ISO 26262, ACLB or ACLD here is not. So I think ACLB is the highest level that here is achieved for the exemplary product. The timeline is about 18 months. So it's a very, very rough estimation here, so don't take it as granted for every product. But let's say if you're starting from some kind of vanilla processes that any software company might have, you can expect to reach, it's reasonable in 18 months, considering the full participation of the company and consultation and training, etc., that you can reach the ACL L2, for example, ASPICE L2 and TSAX L2 and ISO 26262 ACLB, for example, for some software part, etc. So this is just in a nutshell to give you some numbers. So it depends on many, many, many things, but it is possible to. So if you are a company that wants to do the transformation and have, I don't know how many people on board, and 1.5, 2 years, you can be a fully transformed company. It's just important to start, okay? So the sooner you start, the better. You can start small, of course. You can start with a few people. You can start with FSFA, let's say. This is how the program that runs each fall. It's not a custom program, okay? So it's a functional safety fundamentals for automotive at the UCSD. You can see at our booth, what does it mean? You can take a glimpse of the transformation pipeline. It lasts for 5 months. And it mostly deals with functional safety. So it's not exactly what we were talking about before, but it can be a pretty good starting point for the upskill for some individuals or a part of the team. And the good thing about it is that we are giving away some free enrollment vouchers. For individuals, it's about 3K value, and for teams, it's about 8K value. So if you scan this code, you can fill in the details, and then you can, we will draw the prize tomorrow about the lunchtime. So we will have 3 prizes drawn. So 3 people are going to get this. So you can scan this code now, or you can scan it at the booth. There is also going to be a small stand with a code, so you can scan it. I can leave it a bit more, okay? This is the schedule 2024-25. So for these trainings, there are also addresses also at our booth. You can see how to enroll to the program, and also can get this schedule in a paper format for your reference. Okay, so that was everything from me. So good luck with the transformation if you want to have one. But I think the industry needs it, because we will have a lot of flops if we don't do this right. So the safety culture problem is very prominent and rarely understood correctly in the industry. So this is the opportunity to change that.